In this video we're going to explore what I like to call perfect powers, and really it's in preparation for working with roots, radicals. Okay, so let's get started. The first list we'll make is of our perfect squares. We'll start with our numbers list, and so if I square the number 1, of course I get 1. And if I square the number 2, I get 4. Square 3, I get 9. Square 4, I get 16. Square 5, and I get 25. Square 6, and I get 36. Square 7, and I get 49. Square 8, and I get 64. Square 9, and I get 81. Square 10, and I get 100. And of course we could keep going with this list. Those numbers should be pretty familiar. The perfect squares are the numbers that you get here. They're the result of squaring something, okay? So those are the perfect square numbers, and that list keeps going. Now let's make a similar list for variables, and I'm going to use the variable x, but I could use any variable like y or z even. So if I take x and I square it, of course I get x squared. If I take x squared and square it, I get x to the fourth. If I take x to the third and square it, I get x to the sixth. See how I'm still squaring things. X to the fourth squared is x to the eighth. X to the fifth squared is x to the 10th. And you start to notice a pattern here. These expressions over here, the x squared, x to the fourth, x to the sixth, etc., those are the perfect square variables. Okay? And what you start to notice is that the exponents are divisible by 2. So, for example, 9 is a perfect square, but x to the 9th is not. Okay, a lot of people get confused by that. Also, something else I want to point out that people get confused is 16, the number 16 is 4 squared, but x to the 16th is not x to the 4th squared. Okay, x to the 16th is x to the 8th squared. So be careful about confusing exponents, variables with exponents, and numbers. 9 does not behave the same way as x to the 9th, so be very careful about that. Alright, let's make our next list. So part of this making these lists is to get you to recognize the perfect squares or perfect cubes, etc. But it's also to show you how to make this list, which can be very useful if you're not as comfortable with these numbers. So perfect cubes, again I'll start with 1 and I'll cube it now. When I cube 1 I get 1. When I cube 2 I get 8. When I cube 3 I get 27. When I cube 4 I get 64. When I cube 5 I get 125. And yes, this list can keep going. Now let's do our variables list. If I take x and cube it, I get x cubed. If I take x squared and cube it, I get x to the 6th. X cubed to the 3rd is x to the 9th. X to the 4th to the 3rd is x to the 12th. So you see all of our perfect cubes come from cubing things. So our perfect cubes are what we have in these two lists, the results of cubing things. And of course, you notice the pattern here for your variables, the exponents divisible by 3. Okay? So x to the 60th is a perfect cube because 60 is divisible by 3. X to the 60th is also a perfect square because 60 is divisible by 2. Okay? We'll make one more list just to get the point across. Perfect fourth, so I'll do the same thing. I'll raise these things to the 4th power. So 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th oops, 3 to the fourth is 81, etc., etc., etc. X to the fourth is x to the fourth. X squared to the fourth is x to the eighth. X cubed to the fourth is x to the 12th. X to the fourth is x to the 16th. And we keep going, and we see that the exponents here are divisible by, no surprise, 4. Okay? So you can imagine how that list would continue. So 1, 16, 81, etc. are perfect fourths. X to the fourth, x to the eighth, x to the 12th, x to the 16th, and so on are also perfect fourths. And of course you could make a perfect fifths, perfect sixth, and the idea is when you're doing roots or radicals, you create whatever list it is that you need. Okay, and it should be pretty quick to make the list. In fact, eventually when you make your list, you probably won't even need to write the stuff that I'm highlighting in green, you know, the left side of each of these. If you can eliminate that, you'll really save some time. You know, just mentally think 1 to the fourth, 2 to the fourth, 3 to the fourth, x to the fourth, x squared to the fourth, x to the fourth, and that would be helpful. So eventually, this process can become much quicker if you avoid writing everything highlighted above in green. Okay? I'm not saying it's bad to write it. You probably should several times, but once you get comfortable, you can just think the green stuff in your head and come up with the other side, and that's really what's important. The stuff in yellow are the perfect powers. Let me make a note of that too. The expressions in yellow are the perfect powers. Perfect squares, perfect cubes, perfect fourths, etc. Okay? So that's